Let's look at the same thing, the perpendicular distance of a point from a line in the vectorial form now. We've already seen the concept that we developed for Cartesian form. In fact, we'll be using the same concept. We'll be using the same concept for the vectorial form. So what I have available is basically these three. This is a bar, this is b bar, and we have the equation of the straight line which is passing from this point a bar, and it is parallel to b bar. So in fact, I'm not saying that the position vector of this is b bar. What I'm saying is this line is parallel to this b bar, right? So you can write the equation of the straight line now. It will be r bar is equals to a bar plus lambda b bar, right? Because it's passing through a bar and it's parallel to this b bar vector, right? This is the equation of the straight line. Now I also have this position vector. So now instead of having like this alpha, beta, gamma, which was your Cartesian form, what I now have is this position vector of this point. So I have the position vector of this, I have the vectorial form of the equation of straight line. How can I get this same distance? How can I get the same perpendicular distance? How can I get the length of this pink line? For that, what I will do is, I will once again do the same thing. Take this foot of the perpendicular. Once I get the foot of this perpendicular, the position vector of this, then I can easily find this distance. Let's see how I can do that. So this r bar represents the position vector of all the points which are there on this line. So how will they be different from each other? It will all depend on lambda. There will be one lambda for which this r bar will become L. So I'm assuming L is nothing but a bar plus lambda b bar. And I want to get the lambda for which I'm able to create this L, right? The position vector L. So how do I do that? So this is your L. Once again, how do I get the PL? How do I get the dRs of this line PL? So I can get, in fact, I can get the vector PL itself here, because PL is nothing but OL bar minus OP bar. OL bar is nothing but a bar plus lambda b bar, and OP bar is nothing but alpha bar. So here is my PL bar vector. Now this PL bar is at 90 degree with this line. So, and this line is in the direction of B bar, right? So if I take the dot product of PL with B, what should I get? I should be getting a 0, right? Because they are perpendicular to each other. So PL is nothing but a bar minus alpha bar plus lambda b bar into, dot b bar is equal to 0. So as you can see, A, alpha, B, everything the only unknown here is lambda. So I impose this condition because I need that lambda for which this r bar is going to become L. And how do I get that lambda? When I impose this condition, that is when I'll be able to get this lambda. So as you can see, we always assume a general point, we impose the condition, and from that condition we end up getting this lambda. So if you just rearrange this, the lambda that you'll be getting is nothing but minus of a bar minus alpha bar dot b bar by mod b square. This is what you will get. So this is your lambda. What will I do with this lambda once again? Why am I finding this lambda out? I'm finding this lambda out so that I can put it here in this, and I can get the position vector of L. So once you put it, you will get the position vector of L as a bar minus this quantity, which is your a bar minus alpha bar into it's dot b bar. This is dot b bar by mod b square into this is b bar. So what I've done is, instead of lambda, I've just put the value of lambda that I've got, and this has given me the position vector of this point L. Now, if I know the position vector of L and I know the position vector of B, simply mod PL will give me the distance. So basically, if I know P, if I know L, I already know P, it is alpha bar. Now I also know L, right? So I'll put lambda in this. If I put lambda in this, I'll get some vector, right? So what I will be getting is a bar plus lambda b bar minus alpha bar. So basically this quantity that you see here, a bar minus alpha bar dot b bar by mod b square into b bar minus alpha bar. This is your this is the vector that I need, and I'll just take the mod of this, and if I take the mod of this, what I'll be getting is this length of this pink line, which is the distance. So We've covered this topic from both angles. We've looked at the Cartesian form. We've also looked at how to find this distance using the vectorial form. This completes the topic. Let's move on to the next subtopic.